In the Extension 1 course, what we need to do is integrate some more functions. And the one of the first ones we want to look at is integrating sine squared x and cos squared x. Because what we need is, we don't have particular rules. Like, we can differentiate them because we can do a chain rule, but we don't have those sorts of rules set up already from the 2-unit course to take into the Extension 1. So what we want to do is do a manipulation of sine squared x or cos squared x, and then be able to get into a form that allows us to integrate them. So what we want to do is use the relationship here, like of cos 2x equal to 2 cos squared x minus 1, or it could be equal 1 minus sine 2 sine squared x, and then we can rearrange that to have cos squared x there being equal to a half outside of 1 plus cos 2x, because we've added the 1 on both sides and divided by a half. Or if we're getting sine squared x by itself, we're going to add the 2 sine squared x, subtract cos 2x to get that, and then divide by the 2 to get the half there. So what we want to do is be able to manipulate and put either in those forms, because we can integrate that one now. We've got rules to integrate in cos of 2x, so that's not a problem to integrate that. That was harder, but this one makes it easier. So if we have a look at the integration of cos squared x, so again, we integrate, we're going to change and do the integration there. Half can come out the front. We integrate the 1 becomes x. Integrate cos 2x becomes a half sine 2x. And so multiplying through by the half, we get the half x and a quarter of sine 2x plus our constant of integration. The only difference we're going to get when it's sine squared x, well, it's 1 minus cos 2x. So again, the 1 integrates to x, cos 2x will integrate to sine 2x, and we'll get the quarter sine 2x, and with the half x out the front. So that's the only difference there is between the two of them. It's just because we've got a different function to integrate there. So let's have a look at questions here. 2 cos 2 squared x. Well, again, the cos squared x is going to change to a half outside of 1 plus cos 2x. So the 2 times the half cancels each other. We're just integrating 1 plus cos 2x. Gives us the x plus a half sine 2x when we integrate the 1 and cos 2x. Integral of 2 sine squared x, well, again, we do the same thing. The 2 will multiply by the half, and we've changed sine squared x to a half, 1 minus cos 2x. Integrate 1 to it becomes x, and cos 2x becomes a half sine 2x. Don't forget our constant of integration. Sine squared of x on 2. Well, again, remember our manipulation here. If it's cos squared of x, then we're working with the double angle formula as such. So cos squared of x becomes half of 1 plus cos 2x, and sine squared of x becomes a half of 1 minus cos 2x. So that's why we get the half out the front, and it's cos of x this one, was double x on 2 gives us the x there. So half outside of x minus sine x, or if you want to write it in that form, that's not a problem. And 2 cos squared of x on 2, well, the 2 is out the front. We change the cos squared of x on 2 to a half of 1 plus cos x. Do our cancelling, and then we can integrate. Definite integrals works the same way. So sine squared of x becomes a half outside of 1 minus cos 2x. Between 0 and 4, we integrate. And then we substitute pi on 4 in. And we substitute 0 in. Well, that's going to work out to 0. 2 pi on 4 gives us pi on 2, which is 1. So we can get a pi on 8 minus a quarter if we're living in the exact form. Question 6 here, we've got cos squared of x between pi on 3 and pi on 6. Again, we do our manipulation, do an integration, substitution, getting the values correct and making sure we're careful with our signs and cleaning up to get that particular value that we're aiming for at the end. We can also do areas. Now, in the 2-unit course, if we had this, we would have been stuck. But in the Extension 1, because we know we can manipulate sine squared x to be 1 half of 1 minus cos of 2x, we can get a function we can integrate. So notice that the half just multiplies by the pi because it was pi y squared. Gives us the pi on 2 out the front. Again, integrate, substitute, and then we're able to simplify and clean it up to get pi squared on 2. And then 8, we can do a rotation of our region to give us a volume. So again, cos squared there allows us to go between doing the volume there, pi cos squared x, and we can do the substitution then. So we get pi cos squared between pi on 6 and pi on 3, and we can do again integrate, put it between the two values, put our values in, substitute our values, and then clean up and get our required values. That's how we use the ideas of integrating sine squared x and cos squared x. It gives us another tool in our integration repertoire, and it works pretty easily because it's just using the substitution of the formula, one of the formulas a couple of the formulas we learn in the further trig work.